So, welcome to lesson 2, unit 13. And if you look at the board, you have find the y ds from first principles by taking an increment ds in x and then finding the limiting value of the y ds for each of the following when x is equal to 0, -1, and 2 respectively. So let's look at the first equation there. Solution. A, y is equals to 6x squared minus 1. That is what you have. Y equals to 6x squared minus 1. You go straight, y plus the 1 is equal to 6 into x plus the x squared minus 1. So what you have become y plus the y equals to 6 into going to have x squared plus 2x the x plus the x all squared. That's what you have for this minus 1. And what you have, so it now becomes, so if you're writing now 6 into x plus the x all squared minus 1. This is what you have after the expansion. So you have the y is equals to, these are ended, minus 1. That would be better for us, so that you don't go and duplicate this minus 1 in this expansion. So we can now say now that the y is equal to 6 into s squared plus 2x to the x plus the x all squared minus 1 minus y. And what is y? It now becomes the y equals to 6 into x squared plus 2x the x all squared minus 1 minus y, which is 6x squared minus 1. So let us expound and see what we have. Then the y is equals to 6x squared plus 12x dx plus 6 dx all squared minus 1. Now expand this one, minus 6x squared. That's what you have. So let us see how we can see what will be eliminated. We'll discover that plus 6x squared minus 6x squared will go away. Minus 1 plus 1 will go away. So the y is equal to 12x dx plus 6 into the x all squared. I think that's all we have. Then we can bring out the x. The y is equal to the x into what? 12x plus 6 now become the x. Since the x, because the s is out. Now we can go further. The y dx, make this one set of formula. The y dx is equal to 12x plus 6 dx. As s tends to the s tends to 0. So the y dx is equal to 12x. Thank you. This is it. values, the y dx is equal to 12x, which means that we have a table from the values that were given, x values, well, x, for the values when x is equal to 0, x is equal to minus 1, and x is equal to what? 2. So we can allow this one to go. That is our boundaries. So if x is 0, 12x becomes 0. So when x is minus 1, 12x becomes minus 12. When x is 2, 12x becomes 24. So can interpret it when x is 0, when s is equal to 0, y is equal to 0. When x is equal to minus 1, y is equal to minus 2. When x is equal to 2, y is equal to 24. So, which means we can plot a graph for this equation. X is equal to 0, y is equal to 0. When x is equal to minus 1, y equals to minus 12. When s is equal to 2, y is equal to 24. Thank you. So having gotten our values of y, when x is equal to 0, y is equal to 0, when s is equal to minus 1, y is minus 12, when s equals to 2, y equals to 24. So we can now come to the table here and insert these values and call these values of y. That when s is equal to 0, y is 0. When s is equal to minus 1, y is minus 12. When s is equal to 2, y is 24. So with these 3 points, we can draw our graph. So if we draw our graph, 0, 1, 2. Then for the minus x-axis, the maximum is minus 1. 0, minus 1. We can just take minus 2. Then for our y, the maximum in the positive y-axis is 24. Let's assume 1 centimeter is equal to 6, or 2 centimeter equals to 6, and 6, 12, 18, and 24. The same position, minus 6, minus 12, minus 18, minus 24. Then let's plot the graph with these 3 points. So with 3 points, you can know the structure of the graph. So if x is equal to 0, y is equal to 0. If s is equal to 0, y is equal to 0. So that is the point. Then when x is equal to minus 1, y is equal to minus 12. Minus 1, y is equal to minus 12. When x is equal to 2, y is equal to 24. S equals to 2, y is equal to So if you look at this graph, it's a straight line graph. So you have seen it, that it's a straight line graph. Then let us see whether the gradient of this graph will agree with dy dx, which is 12x. If you know how dy dx, 12 there is the gradient. So let's look at it and let's see whether it will be. If we draw this component, to match. We draw this component to this component here. And we want to find the gradient of this graph and try to label this graph x2, x1. Here too you have y1, y2. So the gradient is equal to y2 minus y1 all over s2 minus s1. So our y2 is 24 minus y1, which is minus 12, so minus 12 all over x2, which is 2, x2 here is 2 minus 1. So what you have is going to give us 36 over what? 3. So we'll have 12. Y is equal to mx plus c. That is the formula for a straight line graph. From what we have on the board, we discover that it's a straight line graph. That's why we are trying to use this equation to illustrate this diagram, where m is the gradient from what we have gotten, is 12, and c is the intercept, which is 0. So if you look at your graph, you discover that the intercept is equals to 0. So y equals to mx plus c. And if you relate it to our equation, you discover that y is equals to 12x, where 12 is the gradient value, gradient from the curve, multiplied by any value of x that will make up your what? Your y. So gradient is actually 12 multiplied by any point of what? The value of x. So plus a c. And for this graph, your c is 0. Thank you.